Okay, I apologize for not being able to be there this morning. This was kind of a last minute thing. But anyway, what I want to do today is still walk you through some practice problems on limiting reactant and percent yield, and let you know about one change that we're going to have coming up this week. Now, on Thursday, we're still having a vocab quiz on units 7, 8, and 9. I can tell you all the vocab from every single unit is going to be on there. But what we're going to do, because quarter 3 ends on Monday, the 17th, and our test for unit 9 technically is not going to be until quarter 4, I'm going to change the quiz from a quiz to a test. So it will go in under test grades. So for those of you who did not do super great on your unit 7 and 8 test, it's going to give us, I think, a straightforward opportunity to potentially bump that up just a little bit. So it still will be exam view, it still will be matching, but we're going to change it from a vocab quiz to a vocab test over all of the words on unit 7, 8, and 9. So if you have any questions, let me know, but when we come in Thursday morning, that will still be the first thing that we're going to do. Plus, we'll get the entire block to do more practice problems with this stuff, and so if you have questions, I'll be there the entire time on Thursday, hopefully without a problem. The only thing that I'm going to do also is make your lab available to you today, so that if you kind of hit a standstill with the problems and you have some extra time, that you can make sure that you make the most of that time and get something done. Okay? All right. Now, like I said, what I need you to do, everybody should have a textbook. If you don't have a textbook, then we need to pause this and make sure you get them. But everybody in your textbook hopefully should be open to page 313. I'm going to walk you through practice problem F. I'm also going to walk you through a couple of percent yield problems, and then let you get going on things. Okay? So if you look on the bottom of page 313, it says practice says some rocket engines use a mixture of hydrazine, which is N2H4, and hydrogen peroxide, which is H2O2, as the propellant. The reaction is given by the following equation. And I have the equation written down here because we're going to need to set up a chart. Okay? Now, if we look at all of the information they give us, first of all, it's for part A, it says what is the limiting reactant. So the first thing we have to figure out is what is the limiting reactant in this reaction when 0.750 moles of N2H4 reacts with 0.500 moles of H2O2. And first of all, again, I want to point out that limiting reactant problems, we know we have to solve for them when they give us 2 numbers to start with, as opposed to the other problems that they've been giving us 1 number to start with. Now, the other thing we eventually going to have to figure out is how many moles of excess reactant, that's part B, remain unchanged. And then finally, part C, they want to know moles of each product. Okay, and because we're dealing with the products that are on the right-hand side of the equation, that's going to be moles of N2 and moles of H2O. Okay, so that's going to be the last thing we're going to do. All right, so I'm going to go ahead and set up a chart. For those of you who do dimensional analysis, feel free to set it up that way. You'll be able to see if you have the right answer or not based on what I've gotten. But I'm going to show the chart for right now, and then if you need me to explain dimensional analysis later, I can, because the results were overwhelming that the majority of people are using the chart for stoichiometry, and so since I'm not there to show you both ways, we're going to go with this, and then I can get the dimensional analysis people caught up later if we need to. Okay, first of all, in our chart, whenever we have the given amounts of something, and we have to figure out excess reactant, this is when you have 2 columns for those substances. Now, I do want to point out, it's not that I am splitting those substances in half. I'm just saying that potentially I have 1 column for what is available and 1 column available for what is needed. So that's the only reason available and needed. Okay, the only reason I have those 2 columns there is that I might need it. Then I go ahead and plug in my numbers. I'm starting with 0.750 moles here and 0.500 moles here. My change is 1 for the N2H4. Why? Because there would be a 1 there. 2 for the hydrogen peroxide. Since I'm going down the chart, I'm going to divide. So it's going to be 0.750 divided by 1. That's going to be 0.750. Then you've got 0.500 divided by 2. That's going to be 0.250. Now, instantly, as soon as we know that this is my smallest x value, that is my limiting reactant. So I'm going to start a little place where I'm going to write out all the answers down here. The answer for a limiting reactant is always the chemical. So in this case, it is the hydrogen peroxide. So a lot of times I'll come up here as well and label hydrogen peroxide as my limiting reactant. Why do I know it's my limiting reactant? Because it has the smallest x value. Okay, smallest x value. For those of you that want to do dimensional analysis, you have to convert one to the other and see if you have enough to react, and that's how you can figure out what's left over. Now, because this is my limiter, I'm not going to have any left over. I'm not going to have any needed, for the reaction. So needed will let me figure out how I need to figure out what's left over. So the next problem is to figure out moles of excess. Okay, I take that 0.250, I move it over here, multiply it by 1, I get 0.250. But remember, that is not my answer. My answer is that I have to subtract these two. So if I take 0.750 and I subtract 0.250, that's going to tell me that my moles of excess reactant is going to be 0.500 of the hydrazine, or N2H4. Okay? So, if I come back up and check, I found moles of limiting, or found what my limiter is. I found my moles of excess. Now I have to go find the moles of product, which is going to be both nitrogen and water. So, what do I do? The only number I can move is my smallest x value. So I take 0.250, move it over here, move it over here. Now, for moles of nitrogen is 1. Moles of water is 4. Since I go back up the chart, I multiply. So I'm going to take 0.250 times 1. That's going to be 0.250. Take 0.250 times 4. It's going to be 1.00, keeping with significant figures. So finally, my final answer is that I'm going to have, 0.250 moles of nitrogen is one of my products, 1.00 moles of water as my other product. Okay, so those are my 4 final answer. Now I could have tried to cram in my labeling, whoops, maybe there, and if you don't have space like I do, please rewrite it so that I don't get frustrated that I can't read it. Alright, now what I want you to try to do, is I want you to try to flip the page, look on page 315, and on the bottom there are 2 practice problems. Practice problems I want you to do both number 1 and number 2. Now I'm going to go ahead and set up the known and the unknown for both of these just to kind of get you set up, and I will post the actual solutions on my big campus. You do have to have these written down. I will check to make sure that you have them done by the next time that I see you. So even if nothing else, try them on your own, go to solutions, see how they were supposed to be worked out, so you get some more practice on these. Okay, so for this one I've got 2.00 moles of zinc are reacted with 1.00 moles of sulfur, and we need to know a few things. One, I have to find the limiting reactant. They already give me the balanced chemical equation for this problem. I also need to know the moles of excess reactant. I also need to know the moles of product that are formed. So if you look really quick, this is exactly what you just did right here for this problem right here. You had to find limiting reactant, you had to find moles of excess, and you had to find moles of product. So you're going to tackle number 1 the exact same way. Now for number 2, it's not much different. First of all, you have to have a balanced chemical equation. So for number 2, you're going to do your best on a balanced chemical equation. I will leave the solution for the equation so that you can check it again on my big campus. So you need to write an equation first. You also are starting with 2.40 moles of carbon. Carbon is not part of Hunkel Fibber. People will try to overgeneralize that. So you do not have to make it C2. You're going to react that with 3.10 moles of steam, which is water. Now for what you're trying to solve for, Okay, you first need to find the limiting reactant. Okay, you're going to do that exactly the same way by finding the smallest x value if you're using the chart. You also need to know how many moles of product. Okay, so you'll do that same way. The only thing that's different here is you also have to find the grams of product. Okay, the grams of product. And all you're going to have to do to find grams of product is, instead of stopping at moles, what you're going to do first to find the moles, you're going to go all the way to grams. Okay, exact same way. All right, so the first thing you're going to do, and again, all of this will be on my big canvas, is to do the practice problems on the bottom of page 315. Okay, the next thing that I want you to refer to is to go ahead and look at the little half sheet. It said percent yield problems, because that's the other thing that I need to remind us of, is that not only is it just limiting reactant problems, but it also is percent yield. Now, for percent yield, somewhere up at the top of the paper, I want you to write the percent yield equation, and that's going to be that percent yield is equal to actual yield over theoretical yield times 100. Okay, so let's solve a couple of these and see if we can't figure this out. All right, 2.45 grams of HF were collected. Anytime you see collected, gathered, recovered, this means actual yield. Okay, so my actual yield here is going to be 2.45 grams. My theoretical yield is 3.01 grams. And I'm looking for the percent yield. Now, I'm not going to give you the answers here. I'm just going to set this up so that you can try to solve them, and then I'll put the solutions on my big campus again so that you can check. This also will be something that I need you to have done by the next time. Okay, so percent yield is equal to AY over TY times 100. So back to plugging and chugging, we have to have all of our numbers there. We're going to take 2.45 divided by 3.01 times 100. That's going to give you an answer with 3 significant figures. Okay, and I'll post the answers on my big campus. Why only 3 sig figs? Because my data only had 3 sig figs to start with. All right. Now, if we look at letter B, well, there we go. Okay, this time we're starting with 3.10 grams of hydrogen, which is H2. And a reaction, it says, in a reaction, and 58.9 grams of hydrofluoric acid were actually produced. Okay, well that's going to mean that my 58.9 grams of hydrofluoric is equal to my actual yield. Okay, the unknown, it wants to know percent yield. And I give you a hint. It says hint, you have to find the theoretical yield, which in grams of hydrofluoric acid, and then use that with the given actual yield to find the percentage. Okay, what the heck does that mean? Well, here's my equation. H2 plus F2 gives me 2HF. And I'm going to set up my chart. Grams, molar mass, moles, change, and X. I plug in 3.01 for my grams of hydrogen. And I have to solve for all the way over to grams of hydrofluoric. This will be my theoretical yield. So I then will have theoretical yield and actual yield to find percent yield. Okay, so I take 301, I go grams to grams, all the way over. That becomes my theoretical yield, and then I can solve for it. Okay, so you should have plenty of time. Again, like I said, what I want you to work on, first thing that I want you to do is the practice problems on the bottom of 315. I then just want you to work through, make sure you can solve these 3 problems on the percent yield problems. All of this, the answers, solutions will be in my big campus so that you can check it as you're going. So you're going to work on practice problems. I also will post the stuff for the lab so that you can go ahead and get pre-lab out of the way, done, and then you can study for your vocab quiz. So bring up Quizlet and work on it. Okay? Be good. You guys usually don't give me problems. Come see me if you need me before Thursday.